There we go. Now you know you're recording. All right. So new notation. Just like anything else in math, our notation always means something. And I want to make sure you know what this something means. This notation means this. This guy here, this is the definite integral, represents the area. This is an area question bounded by four things. Bounded by the graph of f of x, the x-axis, and the vertical lines x equals a and x equals b. That notation just means go find me some area. Go find me the area bounded by four things. Whatever the graph of f of x is, the x-axis, and the vertical lines x equals a and x equals b. So if I'm looking over here, if this is my graph of f of x, what's the area that I'm looking for?
Between x equals a.
Between the vertical lines x equals a and x equals b.
Yeah.
Where else? Bounded, has to be trapped by, bounded by f of x, the graph. And the x-axis. So I want you to shade this part in just so it's really clear in your nose. Okay, this is the area that we're looking for. If I were to remove one of the boundaries, we would no longer have bounded area. Right, some calculus teachers will say, oh, it's the area underneath f of x from x equals a to x equals b. What's the problem with that? Brian, what's the problem with that?
There's more below that.
There's more below the x-axis. How much more?
A lot more.
A lot more. How much more?
Infinite.
It's an unbounded problem, right? You have to have all your boundaries in place. And as the unit progresses, I'm not always going to give you the vertical line limits. You're going to have to figure them out.
Yeah.
I'll almost always give you a function, and it will almost always involve the x-axis. But that's what this notation means. It just means go find the area bounded by f of x, the x-axis from x equals a to x equals b. We're good? All right, so let me tell you how to read this so that you can sound like really smart when you go off to college. The way that we're going to read this is the definite integral. The definite integral of f of x from x equals a to x equals b with respect to x. Oh, I think I was supposed to put that down here. Bummer. That notation is the definite integral of f of x from x equals a to x equals b with respect to x. There will be lots of problems where x is not going to be the important variable. It might be t, it might be theta, it could be w, it could be b for Brian, it could be anything. Yeah?
Does it always have to be by the x-axis?
No. Good question. Always good questions. So let's add a little bit here. Okay. Get a little bit of practice with writing that. It's a fancy S. Don't just do like your plain S. You give it a little hook at the bottom, a little hook here at the top. Okay? The x equals a and the x equals b, these are called your limits of integration. The f of x and the dx are referred to as the integrand. The little s here is the integral. And the whole thing put together is what you're going to call the definite integral.
Wait, what? So you have two integrals?
No, you've got limits of integration.
Yeah, I got that.
Okay. You've got the integral sign.
Oh, okay.
Right? Just like we have like derivative notation, that's the integral sign. The f of x combined with the dx is your integrand. And the whole thing, when you put it together, is called the definite integral. Yeah?
What's the dx for?
The dx is to tell you your variable of integration. So when I said with respect to x, that's what the dx is.
Oh.
Brian? Same question?
Where's definite integral from?
The definite integral is everything. The whole thing taken together is what we're going to call the definite integral. Okay? Okay? Don't get overwhelmed. It's just vocabulary, right? And we're gonna use it all the time. What I care about is, what does this actually mean?
Can you repeat what DRX is?
Okay, hold on. Let's get to my question first. What does this actually mean?
The area bounded by.
It's bounded area bounded by 4 things. What are the 4 things?
X-axis.
X-axis.
Oh, X equals A and X equals
The vertical lines x equals a and x equals b. I heard 3 of the 4 boundaries.
Excellent. And graph of f of x.
And the graph of f of x. That's what I care about. This means area. At the end of the day, that's all you need to know. It means area. The vocabulary we'll tighten up on. Okay, the dx is the variable of integration. Okay, we'll talk about that more. A couple of properties that I want to make sure that make sense to you all. All right, note number 1. If I say find the integral from a to a of f of x dx, what is that?
You said a.
From a to a. Trust your instincts.
The definite integral.
The definite integral
of f of x
of f of x
from x equals a to x equals a.
from x equals a to x equals a. Well
How to
done.
X equals A.
From x equals a
At.
to x equals a. From x equals a to x equals a.
But isn't
Go ahead, go for it.
because boundaries they're the same.
They're the same.
Oh.
So what's this equal to?
A.
0.
It should be equal to that.
What does it mean?
Oh.
It means the area bounded by f of x and the x-axis
An A.
from a to a.
Oh, so
How much area is that?
1.
That area is
Zero.
0. It has to be 0. Another note is that area beneath the x-axis, is negative. I know you never actually dealt with negative area in geometry. Area was always positive. In the world of calculus, area below the x-axis is negative. You guys do this with physics all the time, right?
Last year.
With velocity graphs, and the area under a velocity curve means... What does it mean? The area under a velocity graph?
Distance.
Displacement.
Displacement. It really means displacement. It really means displacement, not distance traveled. Okay, good. All right, one more thing. The integral from a to b of f of x dx. If I asked you to find the integral from b to a of f of x dx, the definite integral from a to b of f of x with respect to x, compared to the definite integral from b to a of f of x with respect to x, you think they're the same?
Yeah.
Should be.
Because it's going from B to A to B. So.
The first one is saying find the area starting at A going all the way out to B.
Yeah.
The next one is saying from B all the way back to A. There's a difference.
So
Except for the X.
Direction matters too.
it's because if it was in the it's in the second quadrant. Is
This
that
guy
what
over
you're
here,
talking
second
about?
quadrant?
Yeah. Like if it was going towards the left, does that make it a negative?
Yes.
Back
So-
to physics.
Direction matters, just like in physics, okay? Area above the x-axis is positive. If you're going from A to B, positive area. But if you're going from B to A, negative area. So these guys are going to be equal, but opposite. Yes, sir.
What if it's underneath the x-axis?
What if it's underneath the x-axis? Thank you for rising to the occasion. So what if the area was beneath the x-axis and you were going from right to left?
Turn into positive?
If your area is below the x-axis, that's negative.
Yeah.
But if you're going from right to left, that's a negative.
So that makes it a positive.
That would actually make it a positive area.
Okay, so that's all.
Yeah. Thanks for confusing the heck out of all of us. Great job. All right, so I want to get out of your way. I want you guys to play around with this for a little bit. So I've given you this function, giving you this beautiful piecewise function. Now, not only did I give you the graph, I gave you the equation because I'm a giver. I'm a giver. On the next page are the questions. Unfortunately, I could not get all of this to fit on one page, so you're going to have to do a little bit of back and forth here. But I have faith in your smarticle particles. All will be well. If you're feeling pretty good, just go for it. If anybody wants to do one with me, we can totally talk through one of these together. Anybody want to talk with me through one of them? Okay, so let's do part A. The integral from 0 to 0. God, this is my favorite math notation of them all. So, sexy. Okay. So Anthony, you're doing this one with me. Rogelio, you wanted to do this one with me. Okay. Okay, so what am I asking for?
The area.
I want the area, right? Let's keep it simple. I want the area. Now, if you wanted to read this appropriately, you'd say it's the definite integral of f of x from 0 to 3 with respect to x. With respect to x is important. But all I really want,
The area.
I want the area. So I want the area from 0 to 3. X equals 0, x equals 3. I want some options. What are we going to do? I can think of like 4 different ways to do this.
Break it up into triangles and rectangles.
So you want to break it up into triangles and rectangles? You like that too?
Yes, sir.
Yeah.
Are we gonna have to grab always?
Always? No, of course not. You got to start somewhere. Welcome to the floor. Okay.
Find it. We only do equation.
I'm so glad you are asking all the right questions, Chepe, but right now the question is, how would you find that area? And unfortunately, that's not a pretty shape, right? This is not something that has a name like triangle, circle, square. So, options. I heard break it up into triangles and rectangles. So where do we break it? Jose, where would you break this?
At x equals 2, and then at x, no, not x, y equals 4.
Okay, so it sounds like you want to go into 3?
Yeah.
So like 1, 2, 3?
Yeah.
So if you were to do that, then the first one is going to be a triangle, right? So I'm going to write it this way. I'll say it's area 1 plus area 2 plus area 3. How do I find that first area?
1/2 base times height.
1/2 base times height. Now the thing you need to remember about bases and heights, they're perpendicular. So if you say that the length from 0 to 2 is the base, then it has to be this guy over here, that's the height. They have to be perpendicular. So I'd say that this is going to be 1/2 times 2 times, what's the height? I can't see it from where I am.
4.
1/2 times 2 times 4, plus now I need the second area. Second area, that's a, what is that, a rectangle?
Yeah.
So that's plus 1 times 4, plus that third area, I think that's a triangle. So that is going to be 1/2 times my base, which is 1 times the height, which is, what is that, 4? Okay, let's clean it up. 1/2, 2 times 4 is 4, plus 4 plus 2, so I think we're getting an area of 10. Is everybody getting 10?
Yep.
Okay, that is an option. That is a way.
Anyway.
What's another way?
So how do we use equation?
So
Anybody see another way you could break it up?
calculate.
Oh yeah, that's so true.
Anybody see another way you could break this up?
What's the notation?
And 2 square.
You see a square. Where do you see a square?
It's the name of that one I look for,
Trapezoid.
I think.
Okay, okay. So areas, formulas that you need to know. We know area of a triangle is 1/2 base times height. And area of a rectangle, length times width. Area of a trapezoid is 1/2 the sum of the bases times the height. A trapezoid looks like this.
Oh, down.
Oh, but it's half.
The important thing is that these are your bases. The bases are parallel to each other. And the height is the perpendicular. So could we work with that shape using trapezoid instead?
Yeah.
Yes, but we have to divide by 2.
Right, the trapezoid is probably not natural for us right now. Rectangles and trapezoids are the way to go. I mean, rectangles and triangles are the way to go. But you could say, let me break my shape here, get a trapezoid, and a triangle. And you'd say the base here is 3, the base here is 1, add them together, 3 plus 1 is 4, times that height, that's what, 16? Cut it in half, you get 8. This area over here is 2. Hey, no surprise, area is going to be 10. You can break this up a lot of different ways and still get the same area. I want to get out of your way, let you guys play for a little bit, see what you can do. When you get to part G, call me on over, I'll show you how to do this on your calculator. But not until then. Yes?
You said extend the mean rotation, so you just put the area bounded by x equals 0 to x.
Yeah.
equals 3.
And if you guys don't mind, I'm going to turn the air conditioning on a little bit because
Yeah,
it's hot. I'm starting to smell your cologne in some cases.
Right.
Or wanting to buy you cologne.
What?
Mr. Reyes sending me an email on how to vote.
What?
Yeah.
Vote. Hey.
My wife has already told me how I'm supposed to vote.
Facebook TV. Facebook.
Huh?
You get to put it in this package. Your parents don't understand.
Just when it's out of the just when it's out of
What is this one?
the persecution. I didn't even go to the track, so I just did a different street. Fine, I could be street.
How do you find that? Good.
What's the area of the circle? It's just fine.
And but it's like half semicircle.
No,
Yeah, it's like 4 5.
Which one?
Circle.
This
Those are really nice. Those are basically.
because this is based on
You swing like that
how can I split it?
from 1 to 7. I do like this. There you go. 34.
Yes. The important thing to call something a trapezoid, you need 2 bases that are parallel. They have to be parallel. They could go like this, or they could go like this.
It's in the left.
Wait, what's your answer?
I made a mistake. I thought it was 0. 2
plus
1 is 3.
Wait, pi?
What did you get for your...
No, I'm just ready.
Where did you get pi?
No, for
Yeah. See.
for C.
Oh, no.
You got pi?
I got some pie.
Oh yeah. My favorite. That's what I always tell people. What's your favorite pi? Oh,
That's because you're a little nerd. And I say that with love. Because I raised one.
your daughter?
And none of you are allowed to date my daughter.
Tripping.
I've already picked out.
Maxie?
What?
Maxie. Yeah.
Brian says.
I've got my eye on Maxie. Daisy's little brother.
Almost done.
I'll give him.
All I need to do is slap a bow tie on that boy. And he meets all the criteria.
You know Maxie. It's weird.
Okay, how are we doing over here?
Oh, I don't agree with you.
Oh, I don't agree with you.
The first one is 10, right? The first one is 10. I was just writing the.
First one is 10. Yep.
Did you get
I forgot to
30?
push from.
Wait, are you talking about C?
No, B.
Oh,
Oh, B. Oh, I thought 34.
No.
But then isn't it negative? Plus.
Wait, which one are you doing?
I was thinking, it's
Wouldn't it be
moving
one
this
half?
way.
Wouldn't it be
Plus
pi r?
1 to 0.
Wait,
Oh
for
my
part
god,
B?
this is getting
Or
annoying
minus
for me.
I'm just
Wait,
reading
A,
Am I
you're going
going
from
crazy?
0 to 3.
Okay.
From the lower to the upper.
Oh, yeah, that's what I
Base is chapter. This is the base and this is the other base.
You'll definitely find the trapezoid is convenient. You get to find more area quickly.
How do you label the bases on a trapezoid? Which one is
It's not even a trapezoid.
To be the bases, they have to be
That's what I
parallel.
thought.
It's not even a trapezoid. Okay.
Oh,
So it could be this way,
They just get
or it could be this way. And the height is perpendicular to your bases. That's the important piece.
I got pi. Yeah.
Mr. D,
Yep.
C, did you just get pi?
she wasn't here to do that.
You're close.
Negative pi.
Now you're guessing.
Oh,
But it's a negative
Below
pi.
that.
Why?
Because it's a negative pi.
Why?
Below that.
That's the piece I wanted to hear from you. Because the area you're talking about is below the x-axis, this is negative
One
area.
plus 2.
Okay? Good.
We will stand.
But if it's at 11 to 7,
Now, if it's at 11 to 7, what would happen?
Would it still be negative?
I mean, well, 2 pi. But
If you were going from 11 to 7,
Oh wait, it would be positive.
positive because?
Is it negative and a negative?
Right, you've got one negative in there because you're below the x-axis, and then you're throwing another negative in because you're going right to left instead of left to right.
Is it 33 now?
Yes.
33?
Yes, what was the mistake?
Yeah. I did not count this. This the trapezoid. This
Yep.
is not a trapezoid. This is some other thing.
That's the spirit. That's the spirit.
I just break it apart.
That's not a
This is why I can't put the scissors in the containers. Oh my god.
13 to 7.
Yeah, these have to lose it.
I'm really interested to see what you all can do with E and F. E and F are definitely in
Let's
there
see.
to push your thinking.
Are you just gonna put this as one triangle or what? This one?
0 to K.
Are you just gonna put this one as one more triangle? or
22.
split it into half?
So we did it 1.
Does it matter?
No?
Right, so like, I really want you to tap into your geometry thinking. I'm asking you area, that means lots of options. You should get the same final answer.
Yeah.
Would it be 6 plus 2 pi?
Which one did you find?
Or
From 13 to 7. So let's go to the graph.
No,
it is pi.
And what about
yes,
it?
it is. Yeah.
Area of this and
That's only one.
Uh-huh.
but this would be 6 pi, right? So. and then
I'm
this-
totally messing with your head now.
Yeah,
Not on purpose.
So this would be negative.
Right.
Negative pi, so 6 minus 2 pi.
So it'd be 6 minus 2 pi. But there's
Hey, how do you do D?
6 minus
okay. So tell me about 6. Tell me about this 2 pi.
He knows what I was about to find.
Here would be negative 3.
Ah.
You get it.
So you've got you've got positive area, but because you're going from right to left, it becomes
I was
negative.
going to say with a pencil.
How about up here? Yeah.
So for D, I'm stuck at negative 8 pi plus
1, 2, 3, 4, 5.
Why negative 8 pi?
Me.
from x equals 7 to x equals 11.
Yeah.
The values
No,
are
2
under
pi.
the x-axis.
Uh-huh.
And so that's why I went negative 8 pi.
No,
Why 8
minus.
pi? That's what I don't
Oh,
understand.
negative, yeah.
It's in the equation 2 pi r. Oh wait, that rate.
No, negative.
I'm using the. It's not radius that I'm using. I'm
Oh,
using
I see.
something else.
Fine.
Well,
You said
2
that.
pi r is circumference.
Yeah.
2 pi r is the circumference.
Oh.
I want that area.
Oh, what's the?
So what's the area of a circle?
Pi r squared.
Pi r squared. You have a semicircle. So this must be
Is K around 6?
Is K around 6? Depending on what you mean by around. I'm going to let you dangle it because I really want you to grapple with this a little bit.
The triangle.
It's
I'm gonna write this down.
kind of big.
Yeah, maybe where is the triangle?
X,
Which one?
D.
I wrote 2 pi r for the area.
Me too. But it was
It's not
we had
because
a
it's
two,
positive
so-
stuff.
so now it's squared, it will still be more.
Yeah. But isn't technically pi r
Look at your
squared?
limits of integration.
Yeah, it's pi r squared.
So negative parentheses 6 plus 2 pi.
13 is 7.
13 to 7 is the opposite of going from 7 to 13.
Oh, because it's negative.
So that means it's
2 pi.
6 plus, negative 6 plus.
No, this is positive, so that's 2 pi. 2 pi is positive.
Yeah.
So negative 6.
Right, what you just said is right. He just doesn't listen to you. Let's be real, you all don't listen to each other. You barely listen to me most of the time.
You're getting them.
There you go.
I don't know. I was just doing this one.
Okay. So did you get something like negative 4 pi plus 6?
What's pi?
No, that area's formula is not working well for you.
Pi r squared. Okay, r.
Pi r squared.
No.
Oh, that will be. That actually be.
Oh,
Okay.
It's 2 pi minus 6.
Wait, 2 pi?
Yeah, because
For E?
for E.
I don't know. I'm just gonna leave it like that. You don't have to simplify.
Okay, the only thing I know has to be below 7.
There's a value.
Then
So we're going from K.
What are we doing for
zero.
E?
That means from 2 to 0. We're going to
4.5.
No,
For
but,
E?
but if you look
Oh,
at this
yeah.
one,
How did you do it?
we went to 1 to 7, but it was bigger than 33, so
How did you do
I
E?
just
lower than.
yeah.
Oh.
That's what
Oh, I
I
didn't
Well,
finish reading it.
because the previous answers already
It's
kind
trying to
of.
find K.
Yeah.
All right, so if all went well, for part A you have 10, which we do that together. Part B, 33. Whole lot of folks started with 34 because they were including a part of the triangle they weren't supposed to, but 33. Not just Lucia. Okay, part C, negative pi. Part D, 2 pi minus 6 or negative 6 plus 2 pi. Did anybody finish part E? What do you think?
2 pi minus 6.
E?
Oh, it's D.
No, E.
Oh,
He
okay.
did.
The
He
only,
finished the whole thing.
the only thing I know is that it has to be a X value less than 7.
Yeah.
Or 6, yeah.
Okay, so less than
Because
7.
at 6, I had like an area of 21.5.
Okay. All right, so here's the question I really want you to take a moment and talk to somebody near you. And we're all going to talk to somebody. Part F. For what value of m will the integral from 0 to m of f of x dx be the greatest? I'm not even interested in the work right now, but have a conversation. For what value of m will that definite integral be the greatest?
Yeah.
5.
7.
Yeah. So, because then it goes into a negative.
Oh yeah.
Is it all of them?
Because if you subtract, if you go bigger,
Yeah, 7.
Oh no, if we subtract these here, just
Yeah, if you subtract 9, you get a lower number.
It'd be 34.
Okay, so what's the value of m that makes this the biggest?
7.
7? Okay, right. From 0 to 7, you're only getting positive areas. So like nobody was even thinking like, I'm just going to go to 4. Right? Because if you go from 0 to 4, that's good, but you can always make that number bigger. But what's so special at 7? Why don't you go past 7?
because then it
start
goes negative.
subtracting.
Right, you've got negative area over here. Now, but wait a second, you're right, I get negative area over here, so my number becomes smaller. But is it possible that by going all the way out to 13, I make up for this negative area? Let me ask that question a little bit differently. Everybody's good on 0 to 7.
Yes.
Because after 7, you start to pick up some negative area. But my question is, could you, if you went all the way out to 13, capture enough positive area that you make up for this negative area?
No.
You feel good about your no? Why not?
Well, for the semicircle got negative 2 pi.
Negative 2 pi area over here. How much area over here?
And then I got 6.
6. So this area is negative 2 pi. This area is 6. Negative 2 pi is like negative 6 point something?
Yeah.
Right. Even if you go all the way out to 13, you still have some negative area that you've added on. We're all mostly okay?
Yeah.
All right, I want to show you guys on the calculator. Now, unfortunately, my computer-based calculator is not working right now. We're having an issue across the system. But let's take a look at this. So I want to go menu, actions, delete all. I want to show you 2 ways that you can do this.
What about 84?
You're going to love it. On the 84, well, I'll show you how to do it, but you'll come later. Brian, can you turn off one of the lights? I think that's what we need to do to get it to show up.
Oh, I see it.
So we're just going from the bottom of the top?
Yeah.
God, I really miss being able to do this. Okay. On the calculate screen, trust your instincts. Where are you going to go?
Coordinate equation.
New document.
On the calculate screen, where are we going to go? On the calculate screen.
Oh,
Calculus.
Okay. If you hit menu,
okay.
calculus,
Numerical.
numerical integral,
Yeah.
hit enter. Look at how beautiful that is. Look how beautiful. For you, it's like math. Is it math 0?
Math
Yeah, you
should be math.
Calculus and then.
Or math 9? Okay. Right. Now all you have to do, fill in the boxes. Fill in the boxes. So what's the one that we're looking at?
Integral.
Where is it? From 7 to 9? So 7,
Is that 9?
9. Now, you've got to put in the function.
Yeah, that's what.
And you gave us the function.
From 7 to 9, that's the function I want. Anthony, what was that function?
Negative square root of
Negative square root,
4 minus,
and then is it parentheses?
yeah, parentheses, x minus 9
X minus 9
squared.
squared. Fill in all the boxes,
D of x.
dx. And you should get negative 3.14159. No surprise, what is that really?
Negative 5.
Pi,
2
negative
pi.
pi.
Negative pi, which is exactly what you guys came up with doing it by hand. Yeah.
So how would we plug in one of these equations?
You would have to break this up. Your definite integral is only going to be one function at a time. Okay? All right, one other place I want to show you how to do this. Go back to your home screen. Go to graph. Now with the graph, it's going to be a little bit trickier because you have to have a graph on there first. Okay, the graph that you're going to want to type in, so let's go to tab, and then Anthony, whatever you just told me to type in, do it again. So negative square root 4 minus, what did we say, x minus 9 squared. A little bit of a bummer, my circle has gone off the screen, but I can fix that. I can change my window. Menu, window, zoom settings, and maybe I go up to 12.
Right, you slide.
Okay. So here, what you do is you're going to hit menu. Where are we going to find it?
Analyze.
Let's try analyze graph. Lucia, second calc.
Yeah.
Second calc. Analyze graph. Chepe, what are we looking for? Integral. Go down to option 6 and follow the instructions. It says lower bound. Where do I want to start integrating? I want to start integrating at 7.
Yeah.
Type 7. Hit enter. Now it says upper bound. Where do we want to stop integrating?
9.
Is it 11?
Wait, what?
9.
9? 9, sorry. Now, here's what I don't like. Some folks like the fact that you shade in the graph and how pretty it looks. I think it just kind of makes the graph look a little bit busy. And then you've got this area computation maybe showing up in a place where you don't want it to be. And so you've got to click and drag if you can click and drag correctly, and I apparently messed it all up. Okay? You guys are going to get lots of practice with the calculator skills. We're good? Everybody good? Is this still filming?
Yeah.
Perfect. All right, so now it's time to upgrade your thinking. Now, if this was the AB class, this would be all that we would do today. This isn't the AB class. It's time to go further with your thinking. Yeah. Huh? We're not going to do that one. It's okay. I know. All right. At the top of that page, the first thing says, find the value of that definite integral accurate to at least 3 decimal places. Show me your newfound calculator skills.
Oh my god.
What do you put it in?
I'm gonna throw your volume.
Isn't it the same thing? What's the left one? What did you get, 30 what?
Yeah,
I got something related to 30. Oh no, what about a million? 30. Yeah, it's like older than this.
Okay. So, I asked you guys to go from 0 to 4. That's the issue. So what are you guys getting for the area from 0 to 4?
30.
Approximately
611.
30.61.
30 and 600.
30.611.
Mm-hmm.
Okay, so Jose, have I ever had you drive the laptop before?
No.
Do you mind driving? You probably want to take your paper back there.
Oh my god.
Don't make this the only last time you get to drive. All right, so one of the big players in the world of integration is called Riemann, George Friedrich Riemann, who died at the age of 40, which let me tell you, that's not old. That's not old at all. 40 is very, very young. You need to know that. On this side of 40, 40 is very, very young. Okay, so Riemann was a pioneer in this idea of finding area bounded by curve, which we now call a definite integral, right? And Chepe, your question earlier was a really insightful one. You're like, but what about when you don't give me the graph? Or what about if it's not a pretty graph, right? Like, calculus is not going to be just about nice, convenient shapes. If it was, all the calculus you need to know you could do in 9th grade geometry. So the question is, how could you find the bounded area from 0 to 4? How could you find it exactly? And the answer is, you can't. Right now, with the skills and the tools that you guys have, you cannot do this exactly. But I want to show you one of the ways that Riemann started. So what we're going to do is I want you to click Show Left Rectangles. What Riemann did is this. Victoria, you okay? Okay. What Riemann said is, if you want me to estimate the area from 0 to 4, then a way I can go about doing this is I can divide this region up into 4 strips of equal width and construct a rectangle that will then be used to approximate the area, to approximate the true area. We okay with this big idea?
Yep.
Okay, how do we feel about this estimate? Brian, how do you feel about this estimate? This is a good estimate?
Pretty good.
It's a pretty good estimate? Now, how are you making that decision?
We can just close to 30.
Okay, it's close to 30, but it sounds like you're saying, well, like the computer's done all the stuff, and I'm getting 30.857, and the true area is 30.611. What if you didn't know the true area? How would you feel about that estimate? How would you make the decision about good estimate or bad estimate?
It's not a lot of area out of the circle.
Okay, I hear Mr. Smarty Pants. I'm going to go to my calculator. Riemann did not have a calculator back when he was doing this. He didn't. That wasn't a thing. There wasn't even the TI-1 back then. So Brian, how could you make a decision about how good your estimate is?
The amount of area outside the graph.
Okay, so I could look at that now, right? I've got my little, my rectangular strips here, and each of these strips has some area that extends beyond the graph, right? So over